Question number 7. A camera drone of mass 1.2 kg hovers at a fixed point above the ground. The drone has 4 propellers. Okay. At a time of 1 second, each propeller pushes a mass of 0.4 kg of air vertically downwards. Okay. So it is pushing some air over here downwards, and as a result of it, it is trying to hover upwards or go upwards over here. Assuming that the air above the propeller is stationary. Okay. What is the speed of the air leaving each propeller? Now what's happening is that, see, the mass of this complete drone along with the camera weighs something like around 1.2 kg. Now definitely gravity will now try to pull it. What is the force at which the gravity pulls it down? It should be 1.2 multiplied by g, which is equal to how much? Let us calculate this. It will be 1.2 star 9.8, which will be 11.76. 11.76 Newton. Okay. Now, because the air has been pushed downwards, now it is able to stand over there. Okay, it is able to float there. Okay, which means there's an upward force acting. Now he is asking you with what velocity should this one push so that it is able to equilibrium, have an equilibrium. What we do is the upward force given by it will now be equal to m into delta v divided by delta t. What is delta v by delta t? Acceleration. M into a is nothing but force. Now this should be equal to 11.76. That's what is known to us. Now towards it, what we now need to do is we need to find out this value. So what is the mass? So mass of the air pushed by the propeller is 0.4 kg by one propeller. The 4 propellers. So how much will this be? This will be, total mass will be 1.6. 0.4 multiplied by 4. 1.6 into delta v divided by how long? For time, 1 second. 1 second should be equal to 11.76. So let us calculate this. So this should now be delta v. I'll write it down here. Delta v should now be equal to 11.76 divided by 1.6. When I calculate that, I get 11.76 divided by 1.6 will be 7.35. So this should now be equal to 7.35. So therefore, the initial velocity was 0. If I assume that this change in velocity v should be equal to 7.35 meter per second. The answer closest to the C is the right answer.